Good morning, Pacific folks, and afternoon, Mountain. My name is Janie Montblanc, and with me is our co-coordinator, Corey Gooker, who will be manning the chat. And on behalf of the Great Basin Fire Science Exchange and our partners, I'd like to welcome you to this Science Management Brown Bag discussion on fuel breaks current knowledge. Our presenters today are Doug Shinneman, Research Fire Ecologist with the USGS in Boise, and Lance Okeson, Fire Management Officer with the Boise District BLM. Before I start, I'll go over some details. This discussion is meant to be an informal discussion, so that's why we're using Zoom meeting instead of webinar. Although please still keep your cameras off and mics muted during the discussion, unless we have time at the end to open it up. We'll see how it goes. But Doug and Lance will each have 10 or so minutes up front to tell you about their latest fuel breaks work, and then we'll devote the rest of the time to discussing your questions. Thank you so much for providing your questions in advance during registration. We'll get to those questions first, but you're welcome to type additional questions in the chat at any time, and we'll get to them as time allows. So let's start right off. Let's get started. I'll stop sharing my screen, and Doug, if you want to jump on and share your screen.
Okay. All right, can everybody see that okay?
Not yet.
Oh, no.
There we go.
Okay.
Thanks.
All right, and yeah, thank you, Janie. And welcome everyone. Thanks for joining. I just put together a few slides to give everyone a kind of a quick overview on some recent and ongoing research in fuel breaks. So I suspect that many of you on this call understand that fuel breaks are a really valuable management tool to help reduce the spread of damaging wildfire. But I'm going to focus on their use in the sagebrush biome, and more specifically in the Great Basin. We're up to roughly 11,000 miles of new or improved fuel breaks are planned by the BLM over the next several years. And in this region, in the Great Basin and surrounding regions, fuel breaks are often intended to reduce the threat of the invasive grass fire cycle, in which exotic annual grasses promote frequent fire and prevent the recovery of native sagebrush habitat, and creating a very fire-prone situation after the invasive grass fire cycle sort of sets in, really demanding that we do something about reducing the wildfire threat. And there's basically three main types of linear fuel breaks are used in the Great Basin and the sagebrush biome in general: mowed, green strips, and brown strips. The primary goal of mowing is to reduce fuel loads, to reduce flame lengths, usually achieved by mowing the existing vegetation to reduce plant heights to about 6 or 12 inches or so. The primary goal of a brown strip is to remove the fuel loads altogether, exposing the bare mineral soil, and then helping to reduce both fire spread and ignition. So for instance, reducing roadside fire starts. And the primary goal of a green strip is to reduce fuel continuity and flammability by replacing existing plants with fire-resistant perennials, usually using non-natives that are competitive with more fire-prone annuals and are resilient after disturbance. And so that often includes species like crested wheatgrass or forage kochia. And fuel breaks can also be created or maintained using herbicide application, targeted grazing, and other methods. But given the uncertainty in terms of the fuel treatment effects themselves, combined with ongoing ecological change in these landscapes, there are several potential challenges regarding fuel break implementation and management. So for instance, what are the best spatial configurations for fuel breaks and fuel break networks? What are their maintenance needs, and how sustainable will they be over time? How effective will they be, especially under more extreme fire weather conditions? And what are their overall costs and benefits, or benefits and risks? So I'm leading or involved in several projects with other USGS and BLM partners using two main research strategies to provide better fuel break science that hopefully will help to increase fuel break success. So first, we're investigating fuel break monitoring strategies using both field sampling and remote sensing techniques that can help to assess fuel break effectiveness in terms of things like just measuring fuel loadings, as well as assessing fuel break ecological effects. And then secondly, we are engaged in a variety of modeling and spatial analysis projects on fire behavior, but that can also help to design optimized fuel break networks. In other words, creating networks that maximize fire reduction potential while minimizing negative impacts. And of course, there are multiple potential fuel break effects. The desired and beneficial ones include reducing the loss of sagebrush ecosystems, protecting wildlife habitat, and minimizing risk to humans. But fuel breaks could also have unintended ecological effects, such as facilitating weedy species movement, altering wildlife behavior, or even fragmenting wildlife habitat if not carefully planned and implemented. So ideally then, monitoring designs in and around fuel breaks would be stratified to address the influence of land use, different environmental settings, disturbance histories, and so on, depending on the management or research objectives. But long-term monitoring coupled with research is going to be really critical to understanding these interactive effects and to help inform adaptive management strategies in these changing environments. So my USGS colleagues and I have developed a few different sampling designs that measure conditions both inside and outside of fuel breaks. These designs are meant to account for fuel break linear geometry and the potential influence that they may have into surrounding untreated landscapes. I don't have time to go into all the detail here, but we've sampled hundreds of sites located throughout portions of Idaho and Nevada that capture diverse environmental settings, different fuel break treatment types, different fire histories. And we're looking at response variables like changes in vegetation communities, fuels, wildlife usage, both in and around fuel breaks. We're also currently working with Lance and his team to set up a before and after fuel break treatment study for the Tri-State Fuel Break Project, which he may talk about next. And our data analysis is ongoing for these projects, but just for example, using a well-managed fuel break network in South Central Idaho, where we have data, we're seeing that there are likely interactions between the number of times burned and treatment, with a greater reduction of flammable exotic annual grass cover inside the fuel breaks compared to outside. So that's a good thing. And in fact, those differences increase with the number of times burned, with the number of times the landscape is burned. But at the same time, there's potentially some other aspects of fuel breaks that may require paying close attention to. So for instance, we also observe generally higher exotic annual grass cover near the fuel break edge as it goes out toward the surrounding landscape, especially in years with wetter springs, which might suggest the need for more precise herbicide application along those edges. We also noticed that the density of some shrub species appear to be higher inside compared to outside of fuel breaks for many sites, largely due to resprouting species such as rabbit brush that might have implications for long-term community type shifts, or that suggest potential for rapid regrowth of shrubby fuels without frequent and long-term maintenance. Another way to monitor conditions in and around fuel breaks is to acquire remotely sensed data derived from satellite, airborne, or ground-based sources. These images are from a project my USGS colleagues and I just started in collaboration with the BLM to assess fuel break conditions using sensors mounted on an unmanned aircraft system, or UAS. We're able to get true color RGB, multispectral, and surface from motion data that can potentially allow rapid estimates of vegetation cover, especially fine fuels that cure early in the fire season, but also provide highly accurate estimates of shrub distribution and heights of vegetation from the surface from motion measurements. And this kind of potentially rapid acquisition of data could inform managers about the need for regular maintenance, like mowing to reduce woody fuels, or herbicide application to reduce fine fuels. And these data can also be used to train classifications that can be linked to satellite imagery and applied to broader landscape scales. Of course, this monitoring data has a lot of different uses, but one of the things it can do is help to parameterize fuel models and fuel behavior models to assess fuel break ability to reduce fire intensity and rate of spread. For instance, recent research from the SAGE STEP program and USGS have illustrated how factors such as treatment type, time since treatment, fire weather, and percent cover of different vegetation types in fuel breaks can influence fire behavior using various fire behavior models. And of course, this is important because fuel breaks are largely meant to reduce fire intensity to provide strategic locations for fire suppression activities. My colleagues and I have also been modeling to predict various aspects of fuel break effects and effectiveness across the sagebrush biome. Here, for instance, on the left are maps that are showing modeled probability of fuel breaks contributing to wildfire containment throughout the sagebrush biome based on factors like historical fuel break and fire interactions, but considering explanatory variables or factors like surrounding fuel conditions, the fuel break type, fire weather conditions, and other factors. And the figure in the center is simply a spatial assessment of existing fuel breaks relative to habitat for various sagebrush-dependent wildlife. And the figure at right is from a paper examining potential connectivity of fire and fuels in the Great Basin relative to fuel break locations. And hopefully this kind of research will help to develop strategies for fuel break placement going into the future. One last example is that we're also currently working on a project to develop ways to use outputs from national burn probability mapping efforts derived from the large fire simulator FSIM to assess the relative potential for individual fuel break segments to disproportionately contribute to reduction of area burned by wildfire. We're then using that information as further input into another fuels planning model called FORSIS that can help to optimize fuel treatment placement in consideration with other priorities and limitations like protection of wildlife habitat or based on realistic implementation timelines and schedules. So that's really it for me. Just like I said, a whirlwind tour of some of the work we're doing, and happy to take questions a little later. Thanks.
Great, thanks so much, Doug.
Mm-hmm.
All right, Lance.
Hello, everybody. I'll show you a few pictures here. I kind of got focused on the some of the questions that I'd seen were coming in, and again, I see there was a few questions on fuel break effectiveness, and I wanted to spend a couple slides on that because it's been something that has come up time and time again. Can you see that?
Yes.
And again, in regards to fuel break effectiveness, does my cursor move around on there and you can see that?
Yes, it does.
Well, this is fantastic. All right. So what we basically, again, let's just do a quick review of fuel break and what it does and what it doesn't do, because it's really about physics of fire. Okay. It's about physics. It's just simple as that. And everybody's got thousands of these pictures, and whether you've been in fire doing suppression or doing prescribed burns, or you're just a recreationalist, campfire, that kind of stuff, you actually already know these concepts. But a lot of people, I don't think, extrapolate them to what we're trying to do at a landscape level in regards to fire suppression or prescribed fire. And that is, you got a fuel break here in the background. This one here we're just going to call this sage and grass. This is the problematic fuel break or fuel type in the Great Basin that we're all dealing with here. And that is when sagebrush and grass is receptive to fire in the summer, this is the kind of fire behavior you get. And when you get this kind of fire behavior, we know that you pretty much fail. You have a high propensity to fail when you're in this fire behavior. So what a fuel break's trying to do, and Doug was mentioning this already, is basically we're trying to manipulate this fuel bed to where we get this kind of fire behavior. Now we can succeed right here. See how these guys, this is a fuel break that they're standing in, and this is a prescribed fire. And this is how we do prescribed fires. We do the same thing. We use the concept of fuel breaks in prescribed fire. And we know that the fire behavior in this fuel break is going to be different than the fire behavior within the unit. And this is where we have our resources. And this is where we're going to catch spots from this coming on into here. And we know that we can successfully hold all this fire behavior here by modifying these fuels adjacent to it, which gives us access with our fire community. And again, it modifies that fire behavior. So again, back to that question of, is a fuel break effective? Okay, we have always, from day one, forever, defined the fuel break effectiveness. Does it modify the fire behavior? In other words, does it decrease it, right? So if you manipulate vegetation, take it away, redistribute it, run it through a cow, and take it off of the site, you basically go from a fuel model like this, mow the brush, you come to some kind of a grass fuel model, you are going to change the fire behavior from something that is really hard to deal with or impossible to deal with to something that you have a fighting chance with your resources to do something with. That's how we define effectiveness. So I see a lot of people getting hung up on this because I think what they think is that a fuel break is a standalone treatment or a feature on the landscape. We got a fuel break there. Don't worry. The fuel break will catch it. All our fuel breaks are designed to have the fire community present and engaged. And that's what you're seeing in this picture. Fire community present and engaged. So same picture, just moments later. Now we have access by fire vehicles. It's safe for everybody to be operating in this area. And here we are. We're knocking down this step. Now, I've just got this little tank, and I couldn't put this out back here, but I can sure put this out, and I can sure handle this. And I can also move up and down this fuel break all the way around this, and I can have, and that gives me a huge ability to move across the landscape and take on fires that are moving across the landscape, not stationary, right? So that's another big deal about fire or fuel breaks is you gotta have access for your resources. That's why we always build all our fuel breaks along existing roads, because that's the access, and the existing road is also the break in the fuel continuity. All right. And of course, we've been doing this ever since we started fighting fire 100+ years ago. This is real common practice. This is an existing road, and that we've just freshened up with the dozer, and now we're firing out the line. Here's your fuel break, and this firing it out is actually that vegetation manipulation. We're doing it with fire. That's going to actually increase the effectiveness of this fuel break that we did on the fly with a dozer. So again, not a new concept, it's been around for hundreds of years. The other thing is when you're asking yourself, is a fuel break effective? Remember how we're defining effectiveness. Is it making it safer for the fire community to be there? In other words, it's modified the fire behavior. And that's really effectiveness. Now, it's up to the fire community to respond in the right amount, and that with engines and dozers and aircraft and that kind of stuff. But now we've given them something to work from. Now we've given them a safer place to work also. Now, they may catch the fire or they may not, but that doesn't mean that the fuel break didn't do its job. If the fuel break modified fire behavior, that's the effectiveness. And I see a lot of people getting hung up on that. Again, I just threw this slide in. This is just a low sage site, classic. We got them all over the Great Basin. For the most part, we're not mowing our low sage sites if they're significant, because usually the low sage stuff, again, look at how the fire behavior is modified. You're looking at a 4 foot less flame length here. You got just hardly a road at all. And that's what's holding this whole thing. And we're firing this out because there was a big fire over here. Again, using that concept of reducing fuels, reducing the brush. The brush is really what's given us the most problematic fire behavior in the Great Basin, and trying to get it more to a either some kind of a fuel type like this or a grass fuel type, which gives you a lot of benefits. That it burns out quicker, it's easier to hold, and you have lower flame lengths. Again, let's talk about the basic design of a fuel break, all the ones that we are doing in the Great Basin, and that is, again, here's your break and fuel continuity. This is your road bed. That could be a highway, that could be a county maintained gravel road, but it's got to be for this whole package to work together. This has to be somewhat free of vegetation, where the fire doesn't freely move across it. And then this is the area where everybody wants to fight, and that is, how much vegetation are we going to manipulate? How wide are we going to make that fuel break? And I see some of the questions are tailored to that. I have some ideas I can give you on that, and that stuff. And that's what Doug's doing a lot of is, hey, what's happening in this zone? Are we making it worse? Are we making it better? ecologically, that kind of stuff. Those are good questions that we all want to know. But the width of this vegetation or fuels treatment manipulation zone, that's where you modify your fire behavior. And this is where your fire resources are. And when the fire comes out of this, the fire behavior gets modified, comes to the road, and you're more successful here. Now, does that mean it's the end of the story? Nope. Remember, these are vegetated fuel breaks. They're going to burn. It's just at a lesser intensity, and they're going to spot right across this thing. So if you don't have people here engaged, catching the spots, putting them out, and then moving up and down this line, trying to hold this, your fuel break or your fire is going to cross your fuel break if you have the right conditions. Happens all the time. Does that mean that this concept that the physics of fire is not effective? No, it doesn't at all. It just means that that's the world we live in. We have spots, they move across through the air and they get deposited downwind. And so that's where we're at on that. So that's the end of my slides. Quick thing here on the Boise District, we've been, I don't know how to unshare that. I guess go to this. There we go. So here on the Boise District, am I back on there now?
Yep.
Okay. We basically have 3 fuel break areas that we're working on. And each one of them is kind of unique. It's interesting on why we put fuel break strategies into these 3 different areas. One is the tri-state, which is everything south of the Snake River, south of Boise and southwest Idaho. And that's tying in with some fuel breaks that are in Nevada and also on the Vail District in Oregon. And basically that big piece of ground out there is kind of, it's millions of acres. And it is some of it's the last big stronghold of the sage grouse in the Great Basin. And one of the big threats out there is, of course, those huge wildfires we were having, 500, 800,000 acres. And so we're trying to put in some fuel break strategies to help us, give us some something to work from out there when we do have these big fires to help minimize those sizes. Now, it's interesting that fuel break strategy, and I should have grabbed a picture of a map, but you're going to see the difference. So if you looked at the tri-state fuel break strategy, looked at our soda fuel break strategy, and then our paradigm fuel break strategy, these 3 different strategies, you're going to see that the polygons that those fuel breaks surround are really different in each one. And that because there's a whole different change of, or whole different set of values and a whole different fire regime over the top of each one of those. So in the tri-state, a lot of that's just, it's good country. It's got good native vegetation. It's the best of what we have left. Our polygons where the fuel breaks are actually surrounded are enormous. They're hundreds of thousands of acres. Again, back to that thing that Doug mentioned, our fuel breaks habitat fragmentation, and what does that mean to the animals that are landscape animals out there and moving across it? Are these fuel breaks impacting it? We don't really know the answer to that yet, but so we went with fewer fuel breaks over a bigger landscape to be on the safe side. Now, but if you go north and then you go into the soda fuel break strategy, which was the soda fire from 2015, that whole fuel break strategy was basically to keep that fire footprint from reburning and also to protect it while it was rehabilitating, because we put a lot of money into that rehabilitation efforts. So that was to protect those. And then if you go up to the paradigm, which is this area between Boise and Glens Ferry along I-84, our polygons there are really small. They're 10,000, 20,000 acre polygons. And that was all about just trying to break that fire cycle so that we could get some kind of an anchor point ecologically so that we could get the fire return interval back to what it normally should be. And then we could start to do restoration efforts out there. And so those polygons are real tight. And on our district, we are pretty much doing everything in regards to, we're using chemicals, we're using forage kochia in the areas that it's appropriate. And then we're also just, a lot of our fuel breaks are just manipulating existing vegetation, basically mowing brush, getting that brush out of the fuel break, getting it off the roads, because that's the most problematic fuel type out there. And that's what's driving that fire behavior that's so problematic and hard for people to deal with. Between those 3 fuel break strategies, we have a little over 1,000 miles of fuel breaks authorized. We are probably 50% done with implementation on those at this point, maybe 60%. So that's kind of where we're at. I guess I'll leave it there. I think I'm probably up in my 10 minutes, so I'll cut it off there.
Great. Thank you so much, Lance. Those visuals were so good, especially that first one. I really, this is a fuel break. This is not a fuel break. That's so, it's great to see that. Yeah. Excellent. Okay. Thank you, Lance and Doug, for those intros on your work with fuel breaks. So now let's jump into the questions that registrants sent in, and you both answered a couple of the first ones. So let's jump into what are best practices for fuel break siting and maintenance. And Doug, if you want to get on camera too, we can just discuss. Whoever can take the question first. Whoever wants to take it first, go for it.
Well, in regards to fuel break maintenance, I think the question is really asking, and just reword it, and that is when do you know it's time to maintain your fuel break? I think is what I hear them asking. So assume you have a fuel break. Most of our fuel breaks are, again, trying to manipulate existing vegetation, which is usually sagebrush. And a sagebrush steppe fuel type. So we usually do basically a height. You have your mow height that we try to get it down to 6 inches is what most mow decks can go down to. And then when it gets between 6 and, I can't even remember, 6 and 10 inches or something like that, we will we'll maintain the fuel break and remow it. That's how we've set ours up. So it's usually a height on the vegetation on when we're going to maintain that. One of the things we've found, and Doug mentioned this earlier, and that sometimes the brush density inside the fuel break is actually higher than outside, and that's true. Especially when you first put in a fuel break in an existing sagebrush stand. What we've seen is the sagebrush goes crazy. It loves to get mowed because all our mowing happens in the fall. That's when it's seed set. And it helps distribute that seed all over, and it just goes crazy. So you got the sagebrush that's already there that you mowed down that's going to have live stems next to the ground. And then you have this, it's amazing the amount of seedlings that come on in that first year. So what we found is actually mowing sagebrush actually can promote it if you're mowing in the fall. It takes a few years to work through that and get that kind of suppressed, but with repeated mowings, we haven't done any chemical treatments on the brush. You can do that. There was a district that did that, and it was really effective. If you wanted to do that, what we're hoping to see over time is that as we maintain these fuel breaks enough that the sagebrush will actually just kind of fade out or be a lesser part of that fuel break in the future is what we're hoping for.
Great. Doug, do you have anything to add to the siting and maintenance questions?
No, I think, siting is, a little complicated. Obviously, there's a lot of factors that need to be considered into that planning process, expected fire activity, the ignition rates, the current fuel conditions, the juxtaposition of like natural fire breaks on the landscape. Some of the things Lance mentioned earlier is example of how they handled things around the soda fire relative tri-state is a good example of different objectives for different landscapes. I think, certainly the potential for long-term maintenance, successful long-term maintenance is going to be important as well. And then, of course, as mentioned earlier, trying to avoid potentially negative impacts on wildlife communities, considering the potential for invasion. Those are all factors that could be, important. And as far as maintenance, I'm not a practitioner, but I would say that I think that's where monitoring data are really valuable, as well as possibly some other data sources like the rangeland analysis platform or other data sources that might give managers, some additional information in terms of changes in vegetation, biomass, or fine fuels on the landscape. So it really kind of depends on the type of fuel break and what needs to be treated. But I think there are a lot of different sources and really a lot of different considerations depending on the specifics of the fuel break itself.
Yeah, I'll tag on to that too. There's a and we haven't talked about this, but I think it's a conversation we need to have in the West. And I'm not sure how to do this, but or how the end product works. But there is there's a carrying capacity, I guess you'd say, or a top end for this fuel break effort. There's no way, and nobody wants to do this. Nobody wants to put a fuel break on every single road. But again, so if you're going to do any fuel breaks at all, where should you put them, and how should they be designed? And that feeds into your monitoring data and that maintenance. Like I said, our 3 fuel break strategies cover 3 huge issues on our district. There's one other issue on our district that really is going to take 2 additional fuel break strategies, but not as extensive as these other ones. And that's basically the Boise front, which is what we're working on next, getting some kind of fuel breaks across that front, so we don't have another fire that just sweeps the entire thing. We've got to have something going from the bottom to the top, and it's time to take that on. So that's one of our, but we're probably looking at 60, 80 miles of fuel breaks at the most, if that. And then it's up north of Emmett is another area we need to work on. And then this district would probably be, I would say, that's really the problem areas you need to work on. But that's a carrying capacity. So if you said, well, Lance, what's the magic number that we should fund you to maintain and implement and have your fuel break strategies? I would say that, for our district is it probably that 1,000-mile deal is all the fuel breaks that we could ever maintain legitimately, do a good job on them. I think you get past that for our organization, you're going to start doing a lot of fuel breaks and not doing a good job on them. I would rather do fewer fuel breaks and do a good job on them than a whole bunch of them all over the place. And I think everybody's in that same boat. But I think that needs to be said that at some point, well, we're already there. Money is an issue. You can't just keep putting in fuel breaks. You have to maintain those fuel breaks. And they have to be maintained anywhere from 2 to 5 years, depending on where you're at in that fuel break and in its vegetation composition. And that takes almost as much money as putting the fuel break in the first time. So at some point, we've got to come up with a finite number and just go, here's how much money as a nation we're going to put into fuel breaks in the West. Divvy that up and say, each district, figure out what you need to do, maintain that, and there's your baseline. I don't see any other way to do it. And then that forces us to get really specific on things. Not that we aren't already, but we just can't keep putting on fuel breaks forever. I mean, there's just no way. There's no money, or there's not enough money and time to do it. So there's some kind of a break point in there. And I'm just saying, on our district, knowing my budget in our organization, I think that's about it for us. Yeah.
Yeah, were you going to say something, Doug?
I was just just quickly add that I think that's where some of the optimization modeling might be helpful. Obviously, modeling alone isn't adequate. You need to work with the folks that are on the ground and know the landscape. But I think it's a good start in terms of trying to identify priority locations and those sites that might be, give you the most bang for your buck in terms of where fuel breaks might be the most effective, especially given overall, implementation and maintenance costs over time. So.
And you had mentioned you and Lance are working on projects together. So is that something like science? That's a good science management partnership that you're working on.
I hope so. I think so. Yeah, we just started. We're
okay.
trying.
Yeah.
We're out sampling some of the tri-state fuel break locations, and the objective there is to set up a before and after type of a design, so we can track changes over time effectively and know with control plots how those what changes are actually occurring based on not only having pre-treatment data, but also control plots that are being sampled as the study continues. So yeah, looking forward to working with Lance on that. We're just kind of getting underway this year with getting the sites laid out and doing some initial sampling.
That's great. And
Yeah.
that's a good segue into, well, you had mentioned setting up plots monitoring. And so those were the next series of questions were, what are some unique techniques you use to monitor the condition of existing fuel breaks, and then also what monitoring is the most used for effectiveness? And again, going back to Lance was talking about effectiveness, what do you mean effectiveness?
Yeah. Well, I'll just say ours is really simple. Doug's is going to be a lot more involved, and ours is basically a treatment effectiveness. In other words, did we get it mowed to 6 inches or less? So we're doing lots of stubble or height measurements. We do some density, species before and after, so we know what was there before and then after the treatments. A lot of photo plots. We do a few transects, but really quick and easy, moving across a lot of expanses. And then again, we're focusing on, did we do what we said we were going to do, and is it working in regards to when does it need to be maintained, that stuff. That's what we focus on. So
yeah, and I mean, in our research, we're experimenting with a couple of different designs, but part of our goal is to capture fuel loadings, vegetation, wildlife usage, both inside and outside of the fuel breaks, to get a complete picture of their overall effectiveness as well as their effects. And so we're experimenting with designs that run transects perpendicular to the fuel break to sort of try to get a continuous series of measurements of change, both inside the fuel break in terms of fuel loadings, but also outside as well. And other designs where we have parallel transects that are kind of running parallel to the fuel break in the road, but then continue out into the surrounding landscape. On Tri-State, we're really just setting up sort of paired plots where we have an impact plot that'll be inside a fuel break and a control plot that'll be somewhat nearby. So lots of different ways to try to get at it from the science perspective, but not all of those designs are practical for land managers to carry out because they're quite a bit more intensive, and that's I think what Lance was what he was getting at. It would be really good, I think, though, to try to link some of those monitoring efforts to ongoing agency monitoring programs like AIM and so on. And that's another, I think, important area for maybe advancement as we kind of think about monitoring fuel breaks over time relative to the condition of the rest of the landscape that the BLM manages.
Great, thank you both. Let's see, how often should fuel breaks be revisited? Again, this goes back to monitoring you're just talking about. And then Lance, I believe you said every 2 to 5 years, depending on the fuel break, it sounded like.
Yeah, that's what we're finding. The longer the fuel breaks in, that's starting to stretch out. But yeah, the first few years, it's like a year later, you can't even tell you were there. The brush responds so much. But once you get a couple, we're finding by the third maintenance cycle, it really slows it down. You're out to that 5-year on a lot of our stuff before we're having to go do something with them in regards to mowing brush. That's what we're trying to do, is to get the brush out of our fuel breaks. Yeah.
That's great. And another question kind of related is, what do we know about cost benefit analysis regarding maintenance of fuel breaks? So it sounds like you're saying, I think you mentioned earlier, like it costs almost as much like the first couple times you go in to maintain them, but then are you saying as they're maintained, it's lasts longer?
I think the longer it's established on the landscape, it's not gonna get nothing, but it's not so expensive, especially if you're trying to shift a fuel a fuel composition like we're trying to do out here on between Boise and Glens Ferry. Those are our more expensive fuel breaks because we're trying to basically go from cheatgrass and mustard and burr buttercup to a fuel break that's basically forage kochia. And there's a lot more steps, and it's taken multiple years to get that going. And there's chemical, there's discing, there's seeding, so there's a lot of steps. Now, if you just go out here in the tri-state and you're just working with the existing vegetation, basically sagebrush steppe, all you're trying to do is mow in fuel breaks so you can get that brush off your fuel break. those are cheap. You're looking at, less, 50, $80 an acre. Whereas out on the Paradigm, we're into the hundreds of dollars an acre trying to get that established. But here's the thing: once you get the fuel breaks on the Paradigm, or the ones out here on the Snake River Plain with Forage Kochia, once you get those established, they're going to be basically, you won't have to do anything to them. We've had some ones that they put in years ago that are over 30 years old, these Kochia fuel breaks, and we haven't put a penny into them, and they're catching fire still. So a lot of cost up front, but over time, the cost is going to go down to hardly nothing. Whereas the thing about the sagebrush, being out in the sagebrush steppe, like the Tri-State Classic example, we're going to be into that nonstop forever, because there's a maintenance cycle that's built into that we're going to be there. And that's why I think we need to be able to say, as districts, here's how many miles of fuel breaks we're going to be committed to, and that's where we're going to make our stand. And there's that number's out there. We just got to figure it out. I think on the Boise District, we're not too far from having a good pulse on that here. Yeah,
that's great. That's good to hear. Excellent. So let's see. The next question was, what treatments and at what frequency are required to maintain fuel break effectiveness? And I think you just mentioned some of those things. It depends on the fuel break, mowing, if you're just in sagebrush country, or
how fast it comes back. Yeah.
Great.
Yeah, I would just add that, we actually did recently get some funding to look at this a little more carefully, in terms of, because like Lance said, it's kind of a commitment. Once you put those fuel breaks in, you're kind of locked in for a while to maintain them. Yeah. And so one of the things we're hoping to do is to start to link some models of ecological change based on the system type and the treatment type to those long-term projected costs. I know that's something that the agency is really interested in, I think, from a long-term cost effectiveness strategy, to have a better handle on what those long-term costs are across each state and in the office and district office, of course, across the entire West. It's a lot to track, and so I think it's important to have good cost estimates or outlays, or projections in terms of what the expenditures are going to be over time.
Great, thank you. Excellent. So now those are I think the bulk of the general questions that came in. Now we have some specifics. The first one, are native plant species being considered more for certain fuel break projects, such as incorporating curly cup gumweed, etc.?
Yeah, I would like the curly cup gumweed. Yeah, we talk about that all the time. We are definitely open to it. We don't know the logistics of it yet. Something to look into. I would be interested in pursuing that. But yeah, so in our native plants, yes, we try to use native plants where it's going to work. Let's be honest. If it ain't going to work there, and we know that it ain't going to work there, like out here, out of town, where you're in, a 3 to 6 inch precip zone, and it's burned, 9 times in the last 30 years. We have had nothing but failure out there, and that's why we went to the non-native. But for the most part, most of our other fuel breaks, the soda and the especially the Tri-State, we're all using native. We're trying to use existing vegetation, and if we have to supplement it, excuse me, natives are always our first go-to if they're going to work, and that's just it. We're talking a fuel break, and we're talking it's got to work or it's not worth doing. So that's kind of, yeah. But we do try to use natives. Yeah. Once you get above 5,000 feet in this country on our district, natives become a real viable option. They really do. It's that lower country that's so hot and dry, and a lot of it's converted over to annuals already, is where we've been having to use the non-natives. Yeah.
Doug, you're muted.
Thank you. I know there's been a little bit of research on this, but not a lot. There's at least one, or I think one paper that came out recently looking at curly cup gumweed. But there's been some interest, I think, in low stature native bunch grasses too, like post might be able to serve some field break purposes. But understandably, the safety of the wildland firefighters is really critical, and so they need to fulfill their purpose if they're going to be used in concert with fire suppression activities. So, but where there's potential to use them, I think there's we should do more research and find out how well they work, and where they might work, and kind of continue.
I know we could and this maybe somebody in the audience is the person that we need to talk to, but again, here on the Boise District, we already have areas that we could try the curly cup gumweed and already have things authorized that we could do that, and we're willing to drop in a section there and see how it works. I would be curious if we could get it work, because people have been mentioning that for years, and it's like, okay, but how do you do it? I mean, and then it breaks down about right there. You're like, okay, who's got the bag of seed for curly cup gumweed? Okay, who's got those bags? And then how do you plan it? What's the site prep? That kind of stuff. Tell us what that is, and we'll give it a try.
Sure.
Yeah.
In the chat, it says the Aberdeen Plant Material Center is who to contact about curly cups. So it sounds like we can get a project going.
Somebody's got a bag of seed. All right. Okay. Thank you. Yeah.
Great. Let's see, another question. Are there integrated pest management issues to consider for field break best management practices?
We haven't run into that. Yeah. You mean in regards to insects? Is that what we're getting at?
That's all the question said. So maybe.
Yeah, we haven't had any. I mean, we have had a lot of. We've had a couple of summers now that the grasshoppers have literally taken out our seedings out here east of town. That's only happened to us a couple times. Usually when you get up out of the valley floor here, the insects haven't been a problem, but we have had some grasshoppers take out a couple of our seedings out there. That did happen a couple summers ago. Yeah, and we didn't do anything other than just reseed it again. And the next year the grasshoppers weren't a big deal. So yeah.
Yeah, I don't have nothing to add there. I'm not aware of anything, but yeah.
Okay, great. Let's see. So we had someone write in from Texas about managing a closed canopy preserve surrounded by WUI. And so there was a lot of detail to that question, but basically there are 4 to 6 foot high shaded fuel breaks around the edges. Excuse me. And he's wondering, is that enough? And there's another question, another person asked about shaded fuel breaks as well. I'm sorry, excuse me. So let's talk.
I don't know enough about that. I see the question here. I'm not sure what a closed canopy preserve is. I'm not familiar with that term. Now, again, back to our concept of the physics of fire, right? So if you're surrounding vegetation, or the vegetation in your fuel break is 4 to 6 feet high, at a minimum, you're going to get double that flame length. And if the wind's blowing, you're going to get triple and quadruple. And you're going to be most effective with being 4 or 6 feet less flame length with resources. That's just a rule of thumb, but it's a good rule of thumb. It's legit. So if you're already starting out with vegetation 4 to 6 feet high, your flame lengths are going to be already into that problematic flame lengths in your fuel break. And if I'm reading this question right, that's how I take it. And so it says, is that enough? I would get it down to less than a foot, whatever's in your fuel break. Again, back to our original pictures, that your fuel break, you want to be able to access it, and you want it to modify that fire behavior as it comes into it. Now, I realize a lot of the brush in Texas is 14, 20 feet tall. So if you're getting it down to 6 feet, that's an improvement. But if what you're trying to protect is really important to you, I would get it down to a foot. That's just my recommendation. I don't know enough to tell you the honest truth.
So this was my question. It's an ash juniper live oak co-dominated woodland. So the
Oh,
trees are 20 to 30 feet tall, and we're just limbing the lower limbs. As you know, with ash junipers, a lot of those lower limbs are dead and a little bit
yeah.
more available for fire. So we're limbing those up to 6 feet at the first 30 feet from a property line.
Hmm.
And then from 30 to 100 feet, we're going 4 feet high. So the idea is basically just to help them with their home ignition zone, but the
Oh,
whole
gotcha. Yeah.
landscape is still a co-dominated closed canopy woodland.
Gotcha.
And it seems, and our fire history understanding of the area is that it's infrequent, but they're stand replacing, and we're maintaining these preserves for this endangered songbird. And
Oh,
if it's a stand replacing fire, then you have no habitat. So I'm
gotcha.
just confused why they would be managing towards this when they're not reducing the risk of losing the entire stand.
Yeah, thinning out through the stand too, right?
Yeah.
Yeah, I hear you. That's the first thing that I bumped into my head when you said stand replacing, was that if you don't want to stand replacing, you've got to somehow thin the area. But in your fuel break, I'd still take it down, especially that first 30 feet. Your ignition zone is what you were calling it. That should be really minimal fuels. Yeah, and then as you go into the next layer, which again, you're basically feathering it out there in regards to going higher and higher on your fuels. For that, I haven't fought fire in Texas, but I've seen a lot of pictures on those brush fires down there. That seems like a pretty narrow fuel break. You're not going to give if somebody was trying to be in that fuel break, again, remember what we want a fuel break for, again, modify fire behavior. You're working on that, but you also want to have, is it accessible? Not that you got to build a road in it, but is it accessible for the fire community to get in there and be able to operate, right? So if you've only got a 30-foot fuel break in fuels that surround it that are 20 to 30 feet high, I think you're kind of setting the fire community up, or anybody that tries to make a stand in there might be setting them up to fail.
It's certainly what it feels like. And
Okay, yeah. Yeah, it
uh,
seems like a little, not enough, man. Go big.
yeah, but
sounds like you have some restrictions though in terms of the species of conservation concern. Is that part of the reason they're taking a lighter approach to the? Yeah. So it's not my area of expertise, but I do have several research papers on field breaks in woodland and forest ecosystems. A lot of them are more Mediterranean climates, like Southern California or parts of Europe. But I think a few of those deal with shaded field breaks. If you're interested, I could send you a few of those that might provide you some information or some insight.
Definitely. And so one of the other potential issues is that we're on the 100th meridian, and everybody's saying that it's walking east. So we're going to become more of an arid region. So
yeah,
and just a general denial that that's taking place, and that we need to keep managing towards what it should have been, 100 years ago, as opposed to what it may become eventually. What it appears to be coming currently.
Yeah, sounds like a tough problem, both, maintaining those habitats, the ongoing fire risk. And I assume these are probably fairly isolated habitats. Like if you lose them, there's not a lot of, backup options for that particular species.
I think we're going to be an interesting place to watch next few years.
Yeah. Well, good luck. But yeah, I'd be happy to send you some paper. I have a bit of a bibliography on this, so I could send you a few papers that might be useful. So
please, thank you.
Okay, you bet. Jenny, you're on mute.
Thank you.
Mhm.
Thanks. That's such a great discussion. And that's actually the last question that I had from the questions that registrants provided when they registered. So I was going to try a little experiment and we kind of just did it, but I'm going to stop recording here. So this will be the end of the video. Thank you. And we can open it up for the last 5 minutes.